You are welcome back to my channel. We continue on IUPAC nomenclature of inorganic compounds. IUPAC nomenclature of inorganic compounds. In my last video, I've explained the first aspect of this topic, which is IUPAC nomenclature of binary compounds. Under IUPAC nomenclature of binary compounds, I've explained IUPAC nomenclature of binary ionic compounds. Then I've explained IUPAC nomenclature of what? Binary covalent compounds. So in this class, I'm going to explain IUPAC nomenclature of polyatomic compounds. IUPAC nomenclature of polyatomic compounds. If you are new here, kindly subscribe to Royal Learning Channel to have access to my past video. So we are going to talk about naming of polyatomic compounds. Naming of polyatomic compounds. Then what are polyatomic compounds? Polyatomic compounds composed of several atoms bonded together. Polyatomic compounds composed of several atoms bonded together. Composed of several atoms bonded together, or two or more ions. Let me say two or more radicals. Two or more radicals bonded together. So when three or more atoms are bonded together to form a compound, we call such a compound what? A polyatomic compound. Polyatomic compound. Or when two radicals are bonded together, you call this what? A polyatomic compound. Note, when three or more atoms are bonded together to form a compound, that compound is known as what? A polyatomic compound. Or when two radicals are bonded together, so a compound form is called what? Is a polyatomic compound. So we are going to start this topic with naming of radicals. We are going to start with naming of radicals because radicals is very important in naming what? Polyatomic compounds. So examples of radicals. Then what are radicals? Radicals are group of two or more atoms carrying positive or negative charges. Radicals are group of two or more atoms carrying positive or negative charges. So let's start with naming of radicals. Naming of radicals. E.g. OH. OH is called what? Hydroxyion. It is called an hydroxyion. It is called an hydroxyion. So when OH combine with an element, or that is positive ion, we call this what? It will change to hydroxide. It will change to hydroxide. When hydroxyion is bonded with another positive ion, so the hydroxy will change to what? Hydroxide. The hydroxy will change to hydroxide. Then the charge on, because it is an ion, you have to put what? Negative charge. Then I've explained how to derive the number of charge on radicals. I've explained that in my last video. Then another one is NH4. NH4 plus. NH4 plus is called ammonium ion. Ammonium ion. Ammonium ion. It is an ion because it carries what? A positive charge. Then this one is an ion because it carries what? A negative charge. When we have two types of ions, we have positive ions which is known as cations. Then we have negative ions, which is known as anions. So another one is CO3. Then CO3 2 minus. The charge on it is what? Is CO3 2 minus. Now, how can we name this what? This radical. How can we name this radical? The way we can name this one is different from the way we name this one. They will have their own what? Hydroxy ion and ammonium ion. They have their own specific name. They have specific name. But there is a way of naming, so CO3. Then when you have two atoms or the subscript, when you have subscript 2, when you have subscript 2, you call it di. Subscript is what you have at the base. The base is called subscript. So when you have subscript 2, you call it di. When you have subscript 3, you call it tri. When you have subscript 4, you call it tetra. When you have subscript 5, you call it penta. When you have subscript 6, you call it what? You call it hexa. When you have subscript 7, you call it hepta. When you have subscript 8, you call it octa. Then when you have subscript 9, you call it what? Nona. Then when you have subscript 10, you call it deca. You call it deca. Now, oxygen is having what? 3 subscripts, subscript 3. So you call it tri. Then the oxygen will now change to oxo. Oxygen will change to oxo. So you call it trioxo. Trioxo. Then carbon is what? Is called carbonate. Carbon will be what? We change to carbonate. So trioxocarbonate. Trioxocarbonate what? You have to calculate the oxidation number of carbon from this compound. So you calculate the oxidation number of carbon. So let's calculate the oxidation number of carbon from here. So by making our carbon unknown, so it will be CO3 equal to, so it will be CO3 equal to the charge that is on it. You bring the charge on it down, minus 2. CO3 equal to minus 2, that is the charge on it. Now, we are looking for carbon. So C, then the charge on oxygen is 2 minus. The charge on oxygen is 2 minus. Because oxygen is in what? Is in number 8. When you write the electronic configuration of oxygen in ratio form, that will be 2:6. 2 plus 6 equal to what? Equal to 8. So this one, the last shell, which is valence electron, needs 2 more to balance. So therefore, the charge on oxygen is minus 2. So minus 2 times 3 will give us minus 6 equal to minus 2. So C equal to minus 2. Bring this minus 6 down here, we change to plus 6. So therefore, C is equal to what? Plus 4. So this carbon is what? Is 4. So we call it trioxocarbonate 4. Trioxocarbonate 4. That is how to name what? CO3. So let's take another radical. SO42 minus. So what are we going to call SO42 minus? Then we have what? The substrate what? 4. We have 4 atoms of oxygen. 4 atoms of oxygen. Then when we have 4 substrates, we call it what? Tetra. So when we have substrate 4, you call it tetra. So therefore, oxygen will be tetraoxo. Oxygen will change to oxo. So we call it tetraoxo. Then the sulfur will what? Changes to sulfate. Solvate. Solvate what? We have to calculate the oxidation number of what? Of solvate from this compound. So therefore, SO4 equal to, bring this -2 down, that is the charge on it, bring it down here. So we are looking for sulfur. So sulfur is unknown. The charge on oxygen is 2 minus. So -2 times 4 will give us -8. So S minus 8 equal to -2. So S equal to, then S will then be equal to -2. Bring -8 down to this side will give us +8. So equal to -2 plus 8 will give us +6. So the oxidation number of what? Of solvate from SO4 to minus is what? Is +6. So we call it tetraoxosulfate 6. Tetraoxosulfate 6. That is another radical. So let's take another one. NO3 minus. NO3 minus. What are we going to call NO3 minus? We have 3 atoms of oxygen. So when your subscript is 3, so what are you going to call this? You call it tri. So then oxygen will what? Change to oxo. So you call it trioxo. Trioxo. Then nitrogen will now change to 8. That's nitrate. So triazonitrate. Triazonitrate what? So triazonitrate. So the nitrogen, and we look for the oxidation number of nitrogen from this ion. Let's look for the oxidation number of nitrogen from this ion. So nitrogen is our unknown. So let's say NO3 equal to, the charge on it is -1. So bring that -1 down to the front of equal to. Then NO3 now, the charge on what? The charge on oxygen is 2 minus. So -2 times 3 will give us -6. Since I'm looking for nitrogen, so -2 times 3 is equal to -6. So -6 equal to -1. So N equal to -1 plus 6. By the time you move equal to minus to the other side, so N equal to +5. So the oxidation number of nitrogen from this ion is 5. So we call it triazonitrate 5. Triazonitrate 5. Then and so on and so forth. That is how to name what? Radicals. Now let's go back to naming of polyatomic compounds. Let's go back to naming of polyatomic compounds. I'm going to group this naming of polyatomic compound into 2 classes. I'll group it into 2 categories. The first one is naming of polyatomic compound of group 1 to 3 elements. Naming of polyatomic compounds consists of group 1 to 3 elements. Then the second aspect will be naming of polyatomic compounds consists of transition elements. So the first one, naming of polyatomic compounds consists of naming of polyatomic compounds of group 1 to 3 elements. So that is, when your polyatomic compound consists of a group 1 element, that is, it contains what? Group 1 elements. How can we name that? Let's start with the following examples. So we are going to name the following compounds under naming of polyatomic compound, e.g. NaClO. Let's take this one as A, B, NgCO3, then C, Na2SO4. So let's name the following compound. How can we name the following compound? The subscripts of oxygen in a polyatomic compound must be named. You name the subscripts of oxygen in a polyatomic compound, but we don't always name the subscripts of what? Of a metallic atom. You don't name the what? The subscripts of a metallic atom. So what do I mean by the subscript? That is the number that you have at the base. This one is having subscript 1. Then this one, sodium 2, is what? Is having what? Subscript 1. But you don't name the subscript of what? Of a metallic atom. You only name the what? The subscript of what? Of oxygen. Now, to name this compound, you first name the metallic atom. The first thing you name is the what? The metallic atom, or the positive ion. So then followed by oxygen. Then the middle what? The middle atom will be named last. The middle atom will be named last. Then you write the oxidation number of what? Of the middle atom. So the middle atom will be named with the oxidation number. Now for this one, magnesium is what? Magnesium is a metallic atom. So magnesium will be named first. Then followed by what? By oxygen. Oxygen will go with what? With the subscript. Then the middle atom, which is carbon, will be named last, followed by the oxidation number of carbon from this compound. So when you are naming what? A metallic, a polyatomic compound containing what? A metallic atom. The metal, that metallic atom will be named first. The metallic atom will be named first, while the middle atom will be named last. The metallic atom will be named first, followed by what? Oxygen, then followed by the middle atom. So that middle, the atom at the middle, will be named with the oxidation number of that atom. So let's start with this example 1. Then you name this one fully. You name the metallic atom fully, which is what? Na is what? Is a chemical symbol for sodium. So you call it sodium. Then oxygen is what? We change to oxo. Oxygen we change to oxo. So you cannot say mono-oxo, because mono means 1. So you say sodium oxo. Then chlorine will now change to 8. Then the middle atom changes to 8. The middle atom changes to 8. So the atom at the middle will change to 8. Chlorine will change to chlorate. So you call it sodium oxochlorate. Chlorate what? You have to name the oxidation number of chlorine. So you calculate out the oxidation number of chlorine from this compound. You calculate the oxidation number of chlorine from this compound. Then what is the charge on sodium? The charge on sodium is +1. Then how did I derive this +1? Sodium is in number 11. Sodium is in number 11. If you write the electronic configuration of sodium in ratio form, that will be 2:8:1. Then those elements with 1, 2, 3 electrons, or 1, 2, 3 valence electrons, are positively charged. So this one is having 1 valence electron. Therefore, the charge on it is what? Is +1. So the charge on sodium now is what? Is +1. The charge on sodium is +1. So the charge on sodium is +1. Then we are looking for chlorine. Then followed by oxygen. Oxygen is in number 8. That is the atomic number of oxygen. So it shows that oxygen is having 8 electrons. Oxygen is having 8 electrons. To write the electronic configuration of oxygen in ratio form, that will be 2:6. 2 plus 6 equal to 8. But it needs what? It needs 2 electrons to balance what? The octet structure, the outermost shell electron. So therefore, the charge on it is what? Is -2. So the charge on oxygen here is -2. The charge on oxygen is -2. So everything what? Equal to 0. Everything equal to 0. Now +1 -2 will give us -1. So Cl -1 equal to 0. So Cl equal to +1. So the oxidation number of chlorine from this compound is what? Is +1. So we call it chlorate 1. Chlorate 1. So the name of this compound is sodium oxochlorate 1. Sodium oxochlorate 1. So let's name another compound. MgCO3. The metallic atom will be named fully. The metallic atom is named fully. So Mg is what? Is magnesium. Then followed by what? By oxygen. Oxygen. So you name the what? The substrate of oxygen. So when you have 3, you call it tri. When you have 3, you call it tri. So that will be trioxo. So oxygen changes to oxo. Trioxo. Trioxo what? Then the middle what? The middle atom changes to 8. 8. So what are we going to call it? It is carbon. It will change to carbonate. Carbonate. So trioxo carbonate. Trioxocarbonate what? You have to calculate the oxidation number of carbonate out. Calculate the oxidation number of carbonate. So what is the charge on magnesium? What is the charge on magnesium? Magnesium is in number 12. Magnesium is in number 12. So write the electronic configuration of magnesium in ratio form. That would be 2:8:2. 2 plus 8 plus 2 will give you 12. So those elements with 1, 2, 3 valence electrons are positively charged. So since we are having 2 valence electrons here, the charge of magnesium will be +2. So therefore, magnesium is +2 plus, we are looking for carbon, C. The charge on oxygen is 2 minus. So -2 times 3 will give us -6 equal to 0. So +2 minus 6 will give us -4 equal to 0. So C equal to, bring -4 down here, we change to +4. So the oxidation number of carbon in this compound is 4. So we call it magnesium triazocarbonate 4. Magnesium triazocarbonate 4. That is the name of that compound. So let's take one more example before we move to naming of polyatomic compound of transition element. Let's name NaHSO4. NaHSO4. Then sodium is what? Is a positive ion. Hydrogen is what? Is also a positive ion. So the 2 positive ions will be named fully. The 2 positive ions will be named fully. So we are going to name sodium and hydrogen fully. So we are going to call it sodium hydrogen, then followed by what? Followed by oxygen. Then how many oxygen do we have? 4. So when we have substrate 4, we call this what? Tetra. So that will be tetra tetra. Then oxygen changes to what? Oxo. Tetraoxo. Then the middle what? The middle atom will be named last. That is sulfate. So the middle atom changes to sulfur. Sulfur will change to sulfate. Sulfate. Then sulfate what? Sulfate what? So we have to calculate the oxidation number of sulfate out. Then what is the charge on sodium? Is +1. Then the charge on hydrogen is +1 because hydrogen is in number 1. Then plus S that we are looking for. Then the charge on oxygen is 2 minus. Minus 2 times 4 will give us -8 equal to 0. Equal to 0. +1 plus 1 will give us +2. +2 plus S minus 8 equal to 0. So +2 minus 8 will give us -6 equal to 0. Then S equal to, move this -6 down to this side, we change to +6. So the oxidation number of what? Of sulfur in this compound is what? Is +6. So we call it sulfate 6. So the name of this compound is sodium hydrogen tetraoxo sulfate 6. Sodium hydrogen tetraoxo sulfate 6. So let's move to the second aspect, naming of polyatomic compound of transition elements. So when you are naming a polyatomic, when you are naming polyatomic compounds that consist of what? Of a transition element, you name the oxidation number of that transition element. You name that transition element first, followed by the oxidation number of that transition element. So let's take examples on naming of atomic compounds of transition elements. Naming of polyatomic compounds of transition elements. Examples: CuSO4. Copper is a transition element. So you name copper fully because it is a metal. You name copper fully, then followed by oxygen, then followed by the middle atom, that is the atom at the middle. Then you name the what? Copper fully, then followed by the oxidation number of copper from this compound. Followed by the oxidation number of copper from this compound. Now let's name this compound first. What is the Cu? That is the chemical symbol for copper. So we name copper fully. Then followed by the oxidation number of copper. Followed by the oxidation number of copper. Don't forget that SO4 is a radical. Then the charge on SO4 is what? Is 2 minus. The charge on SO4 is 2 minus. Simply, I can calculate the oxidation number of copper out of this compound. Since you know that S is what? SO4 is what? Is 2 minus. So Cu unknown. Then your SO4 is what? -2. Then you say equal to 0. So therefore, Cu will be equal to what? +2. So the oxidation number of copper from this compound is what? Is +2. Is +2. So you call it copper 2. Copper 2. Copper 2, then oxygen with 4 subscripts. When we have 4, we call this what? Tetra. Tetra what? Oxygen is what? Oxo. Oxygen changes to oxo. Then tetra also sulfate. Tetraoxosulfate, that is the middle atom, we change to what? To sulfate. tetraoxosulfate what? Then you calculate the oxidation number of sulfate. You calculate the oxidation number of sulfate. Now copper is what? Is +2. The oxidation number of copper is +2, then plus sulfur. Then oxygen is 2 minus. The charge on oxygen is -2. -2 times 4 will give us -8 equal to 0. So therefore +2 minus 8 will give me -6 equal to 0. Then S equal to what? +6. So sulfate 6. So you call it copper 2 tetraoxosulfate 6. Copper 2 tetraoxosulfate 6. So let's take another example. So another example is K2Cr2O7. So let's name K2Cr2O7. So we have a group 1 element. Then chromium is what? Is a transition element followed by oxygen. Group 1 element, transition element followed by oxygen. So we first name what? You name your group 1 element first, then followed by what? By oxygen, while the middle atom will be named last. The middle atom will be named last. Then when you are naming transition element, you must name the subscript of that transition element. But we don't name the subscript for what? For group 1 to 3 elements. You don't name subscript for group 1 to 3 elements. Like K is what? Is potassium. So you cannot say dipotassium. There is nothing like that. So we don't name subscript of group 1 to 3 elements. But when you are talking about transition elements, you must name the substrate of that transition element. Cr is what? Is chromium. Chromium. Don't forget that the middle number changes to chromate, because this is what? This chromate is at the middle. So you have to name the subscript of what? Of this chromate. So you call this dichromate. Dichromate, because chromate is what? Chromium is what? Is a transition element. So you name the subscript of transition element, especially when that transition element falls at the middle. When it falls at the middle, you name the subscript of that transition element. So let's name this compound. Let's name this compound. Don't forget that we don't name subscripts of group 1 to 3 elements. So potassium remains potassium. So we call it potassium. Potassium. Then how many oxygen? The subscript for oxygen must be named. How many oxygen? That is 7. 7 is called hecta. So we call it hecta. Then oxygen changes to oxo. Hecta, oxo, hecta, oxo what? Then how many chromates now? Chromate is a transition element. You name the subscript of what? Of chromate. Then subscript is, the subscript for chromate here is 2. Then when you have 2, we call this what? Di. You call it di. Then the middle atom changes to 8. The middle atom changes to 8. So middle atom is chromium, but chromium will change to chromate. So dichromate. Dichromate what? Then you calculate the oxidation number of chromate. Let's calculate the oxidation number of chromate from this compound. Then what is the charge on potassium? Potassium is in number 19. That is 2:8:8, then ratio 1. So the valence electron for potassium is 1. Therefore, the charge on potassium will be +1. +1. So the charge on potassium is +1. So +1 times 2 will give us +2. The charge on potassium is +1. So +1 times 2 will give us +2, because we have 2 atoms of potassium. Then followed by our unknown, which is chromate. So 2 times Cr. 2 times Cr will give us Cr2. Sorry. 2 times Cr will give us 2Cr. Then oxygen, the charge on oxygen is 2 minus. Minus 2 times 7 will give us -14. Minus 2 times 7 will give us -14. So -14 equal to 0. Now plus 2 minus 14 will give us minus 12 equal to 0. So 2CR equal to minus 12 will come to this side, change to plus 12. Then divide both sides by 2. So 2 here, 2 here, 1. So CR equal to 2 here, 1. 2 in 12 is what? 6 plus 6. So the charge on chromate is plus 6. The charge on chromate is plus 6. So we call this dichromate what? Dichromate 6. So the name of this compound is potassium heptaoxo dichromate 6. Potassium heptaoxo dichromate 6. Let's take more examples. KMnO4. KMnO4. Then we have potassium here. Then this is manganese. This is manganese. Then oxygen. So potassium is what? Is a group 1 element. So you name potassium fully. Then followed by oxygen with the subscript. Then followed by manganese. Then with the oxidation number of manganese. Then don't forget that the middle number changes to 8. The middle number changes to 8. Then Mn is manganese. Then it will change to manganate. Manganate. Mn is manganese. It will change to manganese. It will change to manganate. So let's name this compound. So potassium first. Potassium. Then oxygen. How many oxygen? 4. When we have 4, we call it tetra. Tetra. Then oxygen changes to oxo. Tetraoxo. Then the middle number changes to 8. Manganese will change to manganate. 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 Manganate what? So we have to calculate the oxidation number of what? Of manganate. Let's calculate the oxidation number of manganate. The charge on potassium is plus 1. The charge on potassium is plus 1. Then plus manganese is our unknown, Mn, plus the charge on oxygen is 2 minus. So minus 2 times 4 will give us what? Minus 8 equal to 0. Plus 1 minus 8 will give us minus 7 equal to 0. Therefore, Mn equal to, move this minus 7 to this side, we change to plus 7. So the oxidation number of manganese from this compound is what? Is 7. So we call it manganese 7. Manganate 7. Manganate 7. So the name of this compound is potassium tetraoxo manganate 7. Potassium tetraoxo manganate 7. So let's take another example of a polyatomic compound with water molecule. A polyatomic compound with water molecule. CuCO3.5H2O. What are we going to call CuCO3.5H2O? So the first thing, you name the compound before the decimal point, before dot. You name the compound before dot first, then followed by the what? By the water molecule. Then addition of water is called hydrolysis. Addition of water to a compound is called hydrolysis. So from here now, water will sound what? Hydrate. The word hydrate is derived from hydration. Then hydration means what? Addition of water. So hydration we change to hydrate. Hydration means addition of water. Then this water molecule we call it hydrate here. Then how many hydrate? That is 5. That is 5. So 5 is what? Is penta. So let's name this compound now. Copper is what? Copper is a transition element. So we name copper fully, followed by the oxidation number of copper from this compound. So let's start with copper. We are going to name copper fully. Copper what? That is, what is the charge on copper? Then don't forget that CO3 is what? Is a radical, and the charge on CO3 is 2 minus. Now Cu plus CO3 2 minus. Then Cu is unknown. Cu is unknown. Then the charge on this CO3 is minus 2. So minus 2 equal to 0. Then Cu equal to plus 2. So therefore, it shows that the oxidation number of copper from this CuCO3 is what? Is 2. So you call it copper 2. Copper 2. Then oxygen is what? Oxygen we change to what? Oxo. Then we have 3 subscripts of oxygen, that is tri. So we change to trioxo. Trioxo. Then carbon what? The middle atom changes to 8. So carbon we change to carbonate. Carbonate. Carbonate what? We have to calculate the oxidation number of the middle atom. Carbonate what? Copper is plus 2. The charge on copper is plus 2. Then our carbon is unknown. The charge on oxygen is minus 2. Minus 2 times 3 will give us minus 6 equal to 0. Equal to 0. So plus 2 minus 6 will give us minus 4 equal to 0. So C equal to plus 4. So the oxidation number of carbon, the oxidation number of carbon from this compound is 4. So we call it carbonate 4. Carbonate 4. So it is copper 2 trioxocarbonate 4. Then dot. Then we are going to name this water molecule. Water which sound what? We change to hydrate. Water is hydration. That's addition of water. Then the hydration we change to what? To hydrate. Then how many hydrates do we have? 5. So we call it penta. 5 is penta. We call it pentahydrate. Pentahydrate. So if you have 6 here, you call it hexahydrate. If you have 7 water molecules, you call it heptahydrate. Heptahydrate. So let's take one more example. Let's look at Na2CO3.10H2O. Na2CO3.10H2O. Na is what? Is a group 1 element. So we don't need to name the oxidation number of that group 1 element. So we call it sodium. I believe that we have named CO3 before. So CO3 is trioxocarbonate 4. Trioxocarbonate 4. Then 10 is what? We have 10 water molecules. Then water changes to hydrate. So 10 is what? Is deca. So we call it decahydrate. Decahydrate. So the name of this compound is sodium trioxocarbonate 4 decahydrate. Sodium trioxocarbonate 4 decahydrate. Then we have polyatomic compounds. Polyatomic compounds in which their naming is similar to binary compound. We have two polyatomic compounds, but their naming is similar to that of binary compounds. So let's take examples of those compounds, like ammonium, NH3, and NH4, which is ammonium, and chlorine. So what will you name this? NH4 has what? A specific name. It has a specific name, which is called ammonium. Then the chlorine will now sound what? Ide. Ide. So we call this ammonium. Chlorine will change to chloride. So this compound now, you call it ammonium chloride. Ammonium chloride. Then another one is NH4OH. NH4 is ammonium, then OH is hydroxy. So a positive radical plus what? Plus a negative radical. So you name the positive radical fully, which is called ammonium. Then the negative radical will change to ide. So hydroxy will change to hydroxide. Hydroxy will change to hydroxide. Then NH4 is known as what? Ammonium. Ammonium. Then hydroxy now will change to hydroxide. Ammonium hydroxide. Ammonium hydroxide. Then another one is sodium and hydroxy-ion. Sodium hydroxy and hydroxy-ion. So you name sodium fully. Sodium, then hydroxy will now change to ide. So you call it hydroxide. Sodium hydroxide. Sodium hydroxide.